Hello. I will be continuing the discussion in semiconductor diodes. So there are things that I will add to this topic. We will be talking about diode specification sheet. So every diode has a specification sheet, and those data sheet uh, have these following datas. First, the forward voltage or V sub F, and then the maximum forward voltage I sub F, the reverse saturation current I sub R, reverse voltage rating, or in the datasheet it is called VR, or that means a breakdown. And then the maximum power dissipation level at a particular temperature. And then there's also the capacitance level, the reverse recovery time or T sub RR, and then operating temperature range. And there are also other datas that you will found in the data sheet, but these are the most important when studying or looking for a diode data sheet. Okay, if the maximum power or dissipation rating is also provided, that is equal to uh, power dissipation equals voltage dissipation times the current. So where I sub D and V sub D are the diode current and voltages. So the power dissipated, if it is a silicon, it is equal to approximately equal to 0.7 volts times the current. Okay, so this is an example of a data sheet. So this is a diffused silicon planar, so kind of diode. So this is the data sheet of this diode. Mo ni siya ang makita ninyo nga datas na diode. Plus, there is also graphs, datas nga presented through graphs para makita ang relationship ng every data sa diode. Okay, so there are BB breakdown voltage, absolute maximum ratings, which are the temperatures, power dissipation, maximum voltage, and currents. If we look here, there is a figure ng diode. You can also see here the diameter of the pin, the length of the diode, and then there's also the materials used in making in manufacturing the diode. And then you can also see here the package weight, which is 0.14 grams for this kind of diode. And then electrical characteristics, makita gihapon ni sa data sheet, it is 25 degrees ambient temperatures unless otherwise noted. Okay, so these data are taken with 25 degrees ambient temperature. Okay, so these are the graphs showing the relationships of each adidas. Okay, let's discuss first part A, or the breakdown voltage. So 125 volts ang iyang minimum voltage at 100 microampere nga current. So mao na siya ang una ninyo makita ang breakdown voltage. So minimum lang na siya nga voltage. Okay, so naran ni sa libro ha, akong ipang discuss na ni sa libro tanan. The reverse voltage rating, or where BR, so BR man ni siya, VV, no, comes from the term breakdown at a specified temperature. Breakdown voltage. Second, absolute maximum ratings, una temperatures. Okay, so this diode can be stored within negative 65 degrees Celsius to 200 to positive 200 degrees Celsius. And then, ang maximum junction operating temperature is 175 degrees Celsius. And then ang lead temperature 260 degrees Celsius. Note the wide range of temperature operation. Always be aware that datasheets typically use the centigrade scale. So when you look at the datasheets of a diode, naka-degree Celsius ang iyahang datas. So 200 degrees Celsius, that is just equal to 392 degree Fahrenheit, and negative 65 degree Celsius equals to negative 85 degree Fahrenheit. Power dissipation. Okay, so it says here in the data that the power dissipation of the diode at 25 degrees ambient is 500 milliwatts. So, muna yung maximum nga power dissipation. So, this is just equal to voltage times current. So, equals 0.5 watts. Linear power rating factor from 25 degrees Celsius is 3.33 milliwatts per degree Celsius. Kaya sabot ani, every 1 degree Celsius nga madugang sa temperature sa diode, mubaba ang iyahang power dissipation by 3.33 milliwatts. So, every degree Celsius. So, kung mahimo yung temperature of 26 degrees Celsius, ang iyahang power dissipation will become 496.66. And then, kung mahimo ang iyahang temperature of 27 degrees Celsius, the power dissipation will become 493.33. So, muna ang pasabot sa linear power rating factor. Okay, if you look here in the graph, power dissipation with in milliwatts, and then ambient temperature is in degrees Celsius, degree centigrade. Okay, so based sa test or sa data sheet, at 25 degrees Celsius, ang power dissipation is 500 milliwatts. So when the temperature is 100 degrees Celsius, or the temperature of boiling water, ang power dissipation becomes 250 milliwatts. Okay, that is the power rating curve na data. Next, maximum voltage and currents. Okay, so let's look at a continuous forward current, 500 milliampere. So, mo na ang iyahang current, forward current sa diode. And then, gitest ang diode at 25 degrees Celsius ambient temperature. So, mo na ang electrical characteristics. Okay, test conditions. If the forward current equals 1 milliamp, ang forward voltage is between 0.60 up to 0.68 volts. And when the forward current is 200 milliamp, the forward voltage is between 0.85 volts to 1 volts. So, tanaw na to ang iyang graph. So, if you look here, at V sub F, forward voltage equals 0.7 volts. The forward current is approximately equal to 30 milliamp. And then at forward voltage equals 1 volt, the forward current is approximately equal to 250 milliamp. So, kung tanaw na to ang graph, gamay lang value nga madugang sa voltage, taas na kaayo ang current nga moagi sa diode. So, So the increase in voltage, there's also an increase in current. Okay, reverse current. So, in reverse current, if ang voltage niya is 100 volts, and then ang temperature, ambient temperature is 25 degrees Celsius, ang reverse current is 0.5 nanoampere. Okay, let's look at when the temperature is 125 degrees Celsius with the same voltage, 100 volts, the current becomes 1 microamp. So, which is bigger, nanoampere or microampere? Okay, so, bigger ang micro because nano is 10 to the power of negative 9. Micro is 10 to the power of negative 6. So, normally, dako ang value sa current with the unit microampere kaysa sa nanoampere. So, in the reverse current, if you look here in the graph, mutaas ang iyahang current with the increase of voltage. Okay, at when VR increases, so reverse current increases. Okay, and there is also a data with the capacitance. Okay, when the reverse voltage equals to 0, and then the frequency is 1 megahertz, the capacitance of the diode becomes 5 picofarad. And then reverse recovery time. So forward current is 10. When forward current is 10 milliamp, and then reverse voltage is 35 volts, and then load resistance equals to when the resistive load is between 1 to 100 kilo ohms, and then ang iyahang capacitive load is 10 picofarad. So, ang iyahang reverse recovery time is 3 microsecond. So, kusog-kusog na siya na reverse recovery time. So, kung tanan nato diri with the increase in the reverse voltage, there's also an increase in the capacitance of the diode. Capacitance versus reverse voltage. And then, dynamic impedance versus forward current. Okay, so forward current, and then dynamic impedance, the R sub D, dynamic resistance. Okay, with the increase in forward current, magkagamay ang iyahang dynamic impedance. Let's look here sa 10K, sa 10 kilo ohms, ang iyang dynamic, iyang forward current is approximately equal to 0.01 milliampere. But, when, there is a 1. But, when the dynamic impedance is 1 kilo ohms, the forward current is approximately equal to, let's say, kung ano siya diri, mga 70 milliamp. So, nagkataas siya. So, that is how we look at a diode specification sheet.